Hi, I'm Caitlin and I'm back with my final video, which is also my Milestone 3 video for my self-designed knee sleeve, which measures various statistics about a person's knee while they do physical exercise, such as the angle of the person's knee as well as the angular velocity of it. So my Milestone 3 I originally designed as implementing the accelerometer and gyroscope, which is an MPU 60/50, which means it's 6 degrees of freedom, so it measures the yaw, the pitch, and the roll of it. And I actually ended up finishing this milestone before any of the other milestones because I had time to work on it while I waited for everything to arrive. However, I just recently sewed it in and found that it works, thank God. So I will now show you it in action. So it's sewed into the crook of my knee so that I can fully get what's happening to my knee. So there's multiple lines, and it doesn't really matter what all of them mean because a lot of it's just like the y-axis of the yaw and the pitch and the roll and stuff like that. So I found that there's actually two awesome uses for this. One is, as I was saying before, with the bend sensor, it's very inaccurate when it comes to telling you what the angle of your knee is. However, this one does it quite well. So if I squat and if I angle my knee out just a bit like I'm supposed to, you can see the slight rise in this, which is actually the y-axis. So because of the way it's sewed in, that's pretty much just measuring how much my knee is indented. Whereas if I squat and it goes inwards, we can see a slight dip, which isn't what we want. The other thing, especially that's prevalent with knee injuries, is a lot of people cut with their knee before they move with their hips, which means that there's a lot of torque and unnecessary force on your knee. And I found that watching this, there will be a slight hitch in small little divots in the data if you cut with your knee and then your hips follow, because your knee has to stop and then start again once your hips follow through. Whereas if you just turn in one smooth motion, it goes very smoothly and there are no smaller divots within the divot itself. So to get all of this data, I didn't write the code for it because it involves Kalman filtering. The data from the MPU 60/50 is really easy to get. It just takes some simple code. However, figuring out what to do with that data is a lot easier said than done. So as I was saying before, I use Kalman filtering, which essentially predicts what it thinks the next value is going to be, and then it compares it to the value that you're actually getting in real time, and it accounts for the differences in it and like an average, a weighted average pretty much. So it successfully eliminates most of the noise, which as you can see right now, these are just little movements from my knee. It's not actual noise. And the only time where it's slightly off, you probably can't even see it, is with the yaw. So the yaw is pretty much going like this with the accelerometer. And since it doesn't have a magnometer built into it, it really loses a sense of where it is, so it just unnecessarily drifts. However, the code compensates for that, and it eventually resets it once it goes to some far out number, and it resets it back to 0. But for my purpose of the knee brace, I don't need to use the yaw, so it really doesn't matter. So yes, thank you for watching.